this Nitish. Recently, I worked on a mini project, part of academics, where my task was to build a machine learning model to predict lung cancer. So today I'll be running through what I did, how I built the model, and also be showing a final application which will be deployed in Streamlit. So getting straight into the video, uh, let me start with explaining the notebook I've trained and explored the data. Here, as first, we import the libraries that are required as anyone would do, and then we use the read CSV function from pandas to load the dataset. And here we display all the data here. So the thing is, the data you see here, data is already in form of numerics. I'll drop the description about the data. But initially we have this as numerics, means someone has already cleaned it for us, or uh, these are just ratings of everything. So getting into the basic info of the data, can already see most of them are in integers, and you have patient ID feature and a level feature as objects. So in here we don't need patient ID, we can't do much with patient ID, which is like literally useless. So we get to drop it in this case. So we drop it and we check the head of the data again, and we explore the predictor variable. So we have to predict the level. If there is a low risk or a high risk, that's what we are going to predict. So we display that single column, and here we get to do some feature engineering. We are replacing medium with high, so the probability becomes like, even if it is 0.5, it will be considered as a high chance. We get to do that, and then we replace again that with numeric numbers 1 and 0. 1 if it is high and 0 if it is low, right? Then we get to display it again and you can see the changes. But it might still be an object, so that we get to convert this to numeric, and then we check for missing values here. We can use the same command here also, and could do the sum here. Can already see like no missing values, data is really clean. Then we can do also a visualization. So this one we don't have any missing values, so you get to see a full red one. If you have any missing values, you might get to see some points, light and dark points here. Then we dive into some data analysis. Here literally we get to explore how many of our patients are like, get to count the rating of smoking. So 1 is the lowest and 8 is the highest rate. So the highest one is with 2, where the category 2, where more than 200 people get to smoke a thing. After that, we explore chest pain feature. Here, the rating of 7 is the highest, where it's like more than 250 is around 290, I think. It's about 300. And then we get to plot a bar plot. Here we get to explore outliers. You can't really see the feature, uh, category 6 uh, seems to have some outliers there. We can get to handle it, or like can literally work with it. We think it won't be affecting much of our performance. Maybe we can try and optimize it in the future. And then we get to do a background gradient map, where like we, we literally get to get the count of everything. Like if it is age of 14, how many people, how many records are there in 14 for smoking. We get to get the counts in each column there. So the highest is at 35. Just like 77 records are there with people at age of 35, and then we get to do the same to all the features, comparing all the features. And then here we get to get the unique values and get to sort them and display them. Here we compare smokers per age. So we previously showed a gradient map, right? We get to show that as a bar plot here. So you can clearly see at the age of 14, like 9 records are there for smoking. Same has been done as a uh, line chart here. The thing is, this one is interactive, so you can get to see all the points. So this one was made using Plotly, so you can get to see it clearly well. Okay. And then we get the column names here. Here we'll be doing some feature engineering to find which variables are highly correlated, because when you get to see, like, we have literally more than 10 variables. One, it won't be good for feeding all 10 variables to the model. It would be very efficient to check the features which are like really correlated with the predictor variable. Here we get to see the level variable, and with the level variables, the most important features are like pathology, occupational hazards, and then genetic risk, chronic lung disease, obesity, smoking, and then you get chest pain, coughing of blood, fatigue, and all. These are like the highest correlations that you have uh, to the predictor variable, which is highest in the sense I'm considering all the features greater than 0.5 percentage of correlation. So these are like the selected columns that I have there, and these are like unique values in each of the feature selected with respect to the predictor variable. With these features, we'll be predicting if the person has a high level of cancer or low level of cancer. And we step into training the model. So here I'm using a random forest classifier first. We get to select all these data from these columns. We only use these for training in the X variable, and we perform train test split, and we initialize the model and fit the model. Also get to try to show the confusion matrix here. I'll show the comparisons finally, because I'll be training 4 different models. So next comes k-nearest classifiers. Here also we do the same, like we already performed train test split, right? We'll be just fitting the data here, and then we'll be analyzing the performance of it. And comes k-means clustering. So these are like all these models are like unsupervised learning methodologies. Nothing here is supervised, because we are doing a classification problem here, and which can be done with a logistic regression, but I wanted to do something else different. I was like mostly worked in supervised, so I thought of, okay, why not to work with unsupervised algorithms. So I gave it, so you can do the same, like if it performs well, can literally use any algorithm. Here I do the same, like I get the data and I get to fit it to the k-means, and again I analyze the performance metrics. We get only 30% accuracy here. Here it seems to be 100%. And here we are building a decision tree classifier. In this decision tree, we do the same here, fitting the data and finding the accuracy, SVM the same, 96.8%. And one comes final accuracy report. Like we have trained 5 different models, and the best performing one was SVM, because the log loss score, which is like literally very low. Log loss score seems to be very low with SVM. Others have a very high log loss score. Also, the models seem to be overfitted. which has to be handled very safely. So you can try to optimize overfitting by using some regularization techniques in unsupervised learning, and get to check if it is really good or not. And in our case, SVM is performing very well with a good amount of F1 score and a very less log loss score. So what I'll be doing here is I'll be saving the trained SVM model, and I'll be again loading the model for testing it. So here I define some parameters and then some ratings here, and with these I'll be predicting it and then printing it. So this is like the whole process. Now when it comes to the Flask application, I'll be showing you a different one. This is like my folder structure. uh, I have static. In the static folder I'll be having a CSS file, and then templates I'll be having two different HTMLs, one for the home page and one for the result page. If you're using Flask, you'll be needing this. But if you're using Streamlit, you won't be needing this very much, because Streamlit could do pretty much of everything by itself. And let me open an account of prompt here and an account of code here. I'm having it in D and this folder. I'll be using first VS Code here for showing you the Flask code. It's like my I got my Streamlit app. So pretty much see I'm importing libraries, loading the saved model, and I'm having the unique values in each parameter. So a user will be numbers between these ranges. You'll get to understand when you see it. I'm setting a title here, and I'm creating drop downs here, and then when the user hits predict, all the magic should happen. So you don't need these three. You're working with the Flask, you might need. I'll also post a future Flask demonstration for the same using these HTML and CSS files. So Streamlit makes it easier, such that you don't need to do much of anything. Just write. If you get to write 40 lines of code, you can deploy an app, machine learning app. So to run the code, what you have to do is type Streamlit run app.py. We have Python app file name. I have to do this. Let me copy this and open it in Chrome. So this is my final application right here. So we'll be having all these features here. So the user has to select the rating of each. Trustology at 4, occupational hazard is 3, genetic risk is 3, obesity, literally high obesity, coughing of blood is high, fatigue is also high. Means when you hit predict, the person has to be treated uh, and very likely to have cancer. So we can also modify these, like when you these are like the important parameters which really affect uh, the cancer variable, the complexity variable. So you can get to play with it and do some exploration, trying different values. So now the person is safe, less likely to get cancer. So what I can infer here is, like, the lower the rating, the person is really safe. If like uh, at least like more than four of the features are like get a rating of more than 5, the person has to really worry. And this is like my final application. uh, I'm currently running this in a local host. You can also go ahead and deploy it on a Streamlit app on their official website. Okay, so thank you.